Developing a rocket is not just a complex technical challenge. It also means staying ready for fierce competition and potential threats from other companies, as the space industry is one of the most competitive sectors out there. Recently, SpaceX's Starship has found itself facing a significant challenge from a newcomer promising to develop a rocket that could surpass Starship's capabilities. Today, we're diving into what this new competitor is bringing to the table and how it might impact SpaceX's plans. Before we delve any deeper, make sure to subscribe to our channel for future updates on Starship and other groundbreaking achievements. Most new companies in the space industry look up to successful examples for guidance, and SpaceX stands as the leading example of success. Since its entry in 2006, Rocket Lab has positioned itself as a serious contender in the space industry, drawing on lessons from SpaceX's approach to innovation. Founded by Peter Beck, Rocket Lab started small but has grown steadily by following similar principles to those that propelled SpaceX, such as a focus on reusability. When SpaceX introduced reusability, they changed the industry by proving that rockets didn't have to be single-use. Their Falcon 9 and Falcon Heavy rockets became models for other companies looking to reduce costs and increase launch frequency. Rocket Lab took note of this. While their smaller Electron rocket couldn't support vertical landings like SpaceX's Falcon rockets, Rocket Lab devised a cost-saving method suited to its size. Instead of landing Electron's first stage, they developed a mid-air recovery system where a helicopter catches the booster as it descends. Rocket Lab also adopted SpaceX's approach to vertical integration, meaning they manufacture most parts in-house. SpaceX set the standard by minimizing reliance on external suppliers, giving them more control over production timelines, costs, and product quality. Rocket Lab applied the same model, allowing them to manage production internally and maintain control over their rocket's development and upgrades. To match SpaceX's high launch frequency, Rocket Lab has steadily increased the number of Electron launches it performs each year. SpaceX achieved rapid success by consistently launching rockets. Similarly, Rocket Lab has aimed for a high launch cadence, reaching a milestone with 10 Electron launches in a single year. One area where Rocket Lab lagged behind in the industry was with heavy-lift rockets. While SpaceX was advancing with Starship, a massive rocket designed to carry over 100 tons to orbit, Rocket Lab only had the small-lift Electron rocket. Electron has a payload capacity of around 300 kilograms to low Earth orbit and stands 18 meters tall. In comparison, Starship, at nearly 120 meters, is intended for missions like large satellite deployments and potential interplanetary travel. And most importantly, without a medium or heavy-lift vehicle, Rocket Lab couldn't participate in programs like the National Security Space Launch. To address this gap, Rocket Lab began developing Neutron, a heavier-lift rocket with a payload capacity of up to 8 tons to low Earth orbit. Neutrons are designed to handle larger payloads and more complex missions. Neutron is Rocket Lab's next big step, as it enables them to pursue a broader range of clients, including those in the U.S. Space Force's National Security Space Launch Program. Rocket Lab again follows SpaceX's path of scaling up capabilities gradually. SpaceX started with Falcon 1, then scaled up with Falcon 9 and Falcon Heavy, eventually working towards the much larger Starship. Rocket Lab is using a similar model with Neutron. Additionally, Neutron utilizes lightweight carbon composite materials instead of traditional stainless steel. This choice improves the rocket's thrust-to-mass efficiency, although it presents challenges in terms of durability during re-entry. Rocket Lab has experience with carbon composites, having used them in their Electron rocket, which has been the second most frequently launched U.S. rocket annually since 2019. Another unique aspect of Neutron's design is its reusable fairing. Unlike traditional rockets that discard their fairings after payload deployment, Neutron's fairing remains attached and partially opens to release the payload. In contrast, SpaceX's Falcon rockets discard their fairings after each flight, necessitating the production of new fairings for subsequent missions. Neutron was only announced 3 years ago, and Rocket Lab has already successfully tested the Archimedes engine, which will power the rocket. Achieving this milestone puts Rocket Lab on track to launch Neutron by mid-2025. Financially, Neutron's development is estimated to cost between $250 to $300 million, making it a cost-effective option in the competitive space launch market. This budget is relatively small compared to the development costs of other medium and heavy-lift rockets, positioning Neutron as an attractive choice for customers seeking reliable and affordable launch services. While many companies like Rocket Lab are working to catch up with SpaceX, SpaceX continues advancing at a rapid pace toward its main goal of making human missions to Mars a reality. Through its Starship program, SpaceX is working on creating a fully reusable rocket system that can handle large payloads for deep space missions. So far, SpaceX has conducted 5 orbital test launches with Starship, and now they're preparing for the 6th test with several upgrades. The first test launch took place on April 20, 2023, from SpaceX's Starbase in Texas. This launch was a significant milestone as it marked the first time SpaceX attempted to send Starship into space. However, shortly after takeoff, the rocket experienced a rapid unscheduled disassembly, which means it broke apart due to issues with the Super Heavy booster. Although it didn't reach orbit, the test provided valuable data that helped SpaceX identify areas for improvement. Since that initial launch, each of the following test flights has shown gradual improvements. SpaceX concentrated on enhancing Starship's Raptor engines, which power the rocket. These engines run on liquid methane and liquid oxygen, offering better efficiency and power compared to traditional engines. Early tests showed issues with heat resistance and pressure management, which SpaceX addressed by upgrading certain components and adjusting the manufacturing process. These upgrades have improved the engine's stability, which is crucial for Starship to reach and maintain orbit. The second and third orbital test flights, conducted in mid-2023, showed progress in flight duration and stability. Starship reached higher altitudes and stayed in flight longer, giving SpaceX the chance to evaluate how different systems operated in real-world conditions. The third flight nearly achieved orbital altitude. However, issues with the separation mechanism between Starship and the Super Heavy booster were identified, leading SpaceX to redesign this system to ensure a smoother disengagement in future launches. In the 4th and 5th tests, carried out in late 2023 and early 2024, SpaceX focused on improving the recovery of the Super Heavy booster. SpaceX is working on a system where the booster is caught using a structure called the Mechazilla Tower as it returns to the launch site. These attempts haven't been fully successful yet, but each trial has provided data on how the booster descends and how the catch system responds. The goal is to eventually make both the booster and the Starship vehicle fully reusable, which would lower costs and allow for more frequent launches. For the upcoming 6th orbital test, SpaceX is implementing upgrades based on previous test findings. This next launch will feature an upgraded heat shield on the Starship vehicle, which is crucial for protecting the rocket during atmospheric re-entry. The new heat shield tiles are designed to handle higher temperatures and reduce wear. SpaceX is also making improvements to the Raptor engines to increase efficiency and reliability. With each test, they've worked to refine the engine design, focusing on increasing thrust while reducing weight. For the 6th test, the gimbal system, which allows the engines to pivot for directional control, has been upgraded to improve Starship's stability during launch. This change will help keep Starship on its intended path more accurately. That's all for today's video. Thanks for watching, and we hope to see you in the next one.